everyone, welcome to my YouTube channel. In this week's video, I'm going to explain to you how you should answer quiz question from chapter 3. So let's begin. Question number 1. The coagulation of 1 milliliter of a colloidal salt of gold is completely prevented by addition of 0.03 gram of hemoglobin to it before adding 1 milliliter of 10% sodium chloride solution. Calculate the goal number of hemoglobin. Alright, so the first step in calculating the goal number is to write what is the formula that you need to use. So goal number is equivalent to the mass in milligram of the lyophilic colloid divided by the volume in milliliter of the lyophobic solution. So this one you need to times 10. Alright, so from the question, you were given the mass of the lyophilic colloid. So the lyophilic colloid is the hemoglobin and the mass given to you is 0.03 gram. So what you need to do now is you need to convert this into milligram. So you need to times 1000. And then you were given that the colloidal salt of gold means that that is a lyophobic solution. The volume is 100 ml. And indeed you want it in milliliter times 10. So just slash this out. So you will end up with 0.3 gram times 10. So this one, your goal number is equivalent to 3.0. So this is the final answer for the first question. Alright, so let's move on to question number 2. The goal number of protection colloids A, B, C, and D are 0.5, 0.01, 0.1, and 0.005 respectively. Determine the correct order of their protective power. To answer this question, you need to understand the concept of the protective power with regards of the goal number. Basically, in theory, we can say that the smaller your goal number will lead to higher protective action. So we're just going to write this again. So your A is 0.5, B is 0.01, and then 0.1 and end up with 0.005. Alright, so from here, what we are going to do is we are going to search for the lowest goal number. So apparently this is the lowest goal number, so D. And then the second one is B. And then followed by C. And then followed by A. Means that this one is bigger than here, bigger, bigger, and bigger. Right? So it means that as you go through here, the protective action is higher because the whole number is lower. Right, so it is inversely proportional. So the lower your whole number means that it have higher protective action. Question number 3. Determine the work done in the formation of liquid drop of diameter 2 cm if the surface tension of the liquid is 0.03 Newton per meter. Alright, so in order for you to answer this question, we are going to choose the correct formula to use to answer this question. So you were asked to calculate what is the work done. So work is equivalent to increase in the surface area times the surface tension. So increase in the surface area, because this is a liquid drop, so it's equivalent to 4 pi r square. So your r square should be the r final square minus the r initial square times your surface tension. Okay, so this is rather straightforward. So you just need to write 4 pi. So the diameter is 2 centimeters. So 2 centimeter when you want to find your radius. So 2 divided by 2 is equivalent to 1 centimeter. But then when you look at your surface tension, it's Newton per meter. So you need to convert the centimeter into meter beforehand. So it means that because this is 1 centimeter, so it's equivalent to 0.01 square minus what is the initial radius. So it's not given to you in the question, so we assume that initially there's no liquid drop being formed, so the radius should be equivalent to 0. And then times your surface tension given in the question is 0.03, right? So 0.03, this one Newton per meter. So therefore here is meter. So you're just going to do this. 4 pi is equivalent to 88 over 7. And then 0.01 square is equivalent to 1.00 times 10 to the power of negative 4. And then times 0.03 Newton per meter. This one should be meter. So you should get your final answer is 3.7716 times 10 to the power of negative 5. So here it should be in Newton. So what should always be in Newton. So this is your final answer for the third question. Alright, moving on to the final question for this week. The vapor pressure of air bubble at certain depth is 1.5 atm. If the atmospheric pressure is 101,325 Pascal, determine the depth of which the air bubble is being formed. Given that the total pressure at depth, the density and the acceleration of gravity is 151,990 Pascal, 0.996 grams per centimeter cube, and 9.8 meter per second respectively. Alright, if you look closely to the question, you were given the total pressure at depth. So total pressure at depth is actually equivalent to the atmospheric pressure plus pressure at fluid. So the atmospheric pressure is given in the question, and now you need to calculate what is pressure at fluid. So the total pressure at depth is given in the question, which is 151,990 Pascal, and the atmospheric pressure is 101,325 Pascal, and then the pressure at fluid is equivalent to rho GH. Alright, so we need to settle with this part of the question. Right, so 151,990 Pascal is equivalent to 101,325 Pascal plus, okay, now your rho is the density, 0.996 gram per centimeter cube. Okay, I'm just going to write it this way first. And then your g, the acceleration, is 9.8 meter per second, and then you were asked to find what is your value of h. Right, so the normal drill that we need to do is we need to make sure that the unit that you're using is actually workable. So this one, centimeter cube, is not feasible because it doesn't match your acceleration. So we need to change it to meter. But then here is in Pascal, right? So you need to change the unit of Pascal into other unit that have second, that have the time, and also have the mass, and also it should have the length as well. So what we can do is we can convert 151,990 Pascal into kilogram per meter per second per second. Right, same goes with here, 101,325 kilogram per meter per second. Alright, so we are going to rearrange this because what we want to calculate is the value of H. So H is equivalent to 151,990 kilogram per meter per second minus 101,325 kilogram per meter per second divided by your rho G. So this one you need to convert first. So after converting, you should get 9.7608 times 10 to the power of 3 kilogram per meter per second. Alright, so should you're wondering how do I get around and getting this unit, is because I've already converted this gram centimeter per centimeter cube. This one I need to convert it into kilogram per meter cube, right? And then because it's rho GH, so I'm going to times the rho and the G. So the rho is kilogram over meter cube times your G, which is the acceleration, is meter per second. So here, so you will end up getting kilogram. And then here, because it turns into 2, so meter to the power of -2, and also per second. That's why we got this over here. Alright, so after the calculation, you should be able to get your H is equivalent to 5.0665 times 10 to the power of 4. So the unit shall be kilogram per meter per second divided by 9.7608 times 10 to the power of 3. So the unit is kilogram second per second. So you should get the height is equivalent to 5.1907 meter. So how do I get a meter as the final answer? Is because this one is kilogram per meter, and then second per second, and then you times this one over kilogram, right? So here is kilogram, so meter, and then so here you slash out here one of those, so you end up getting the unit in meter. So that's the final answer for the last question for this week video. Alright, so that's the end of this week video. I would like to thank all of you for watching this video until the end. I hope this video helps you to understand more on how you should tackle all the questions from the quiz, and all the best for your upcoming test. So goodbye, and I'll see you next week.